In this video, we're going to be looking at the distance formula. And in that, I mean the distance between two given points. And using that formula to prove if three given points are actually form a right triangle. So first of all, if we're given 2 points, A, x sub 1, y sub 1, and B, x sub 2, y sub 2, the distance between A and B is given by the square root of x2 minus x1 squared plus. So the difference between the two x values squared plus the difference between the two y values squared. Okay, so let's look at an example. So, for example, find the distance between, let's say A is the point 25 and B is the point 68. Find the distance between these 2 points. So if you were to plot these 2 points, 1, 2, so A would be somewhere around here. Okay, so if A is here and B is over here, then the distance between these points, so AB would equal to the square root. Okay, so I'll make this one x sub 1, y sub 1, and here x sub 2, y sub 2. So the distance between these two would be 6 minus 2 squared plus 8 minus 5 squared. So this would be 4 squared plus 3 squared. So 16 plus 9. So this is equal to the square root of 25. So this is equal to 5. So the distance from A to B is equal to 5. Okay, let's look at another example. Suppose we have A as the point minus 2 minus 7 and B is negative 7, negative 19. So AB will be the square root. Okay, again, x sub 1, y sub 1. And this one, x sub 2, y sub 2. So we would have minus 7. But here, the value itself have a negative. And so using a parenthesis would help us out there. And here, minus 19, negative, the value itself again have a negative squared. So here we would actually have a minus 7 plus 2 squared plus minus 19 plus 7 squared. So this would be minus 5 squared plus minus 12 squared. So this would be the square root of 25 plus 144. So this would equal to the square root of 169, which is equal to 13. So A to B, the distance from A to B is 13. Okay, so now if we were given 3 distinct points, right, we could check to see if it forms a right triangle. So if we have a right triangle, suppose we have a right triangle, A, B, C, and so the side here would be A, the side here would be A. Okay, let's make this B, and let's make this C here. Okay, so let's make this C. Okay, so we have A, the distance of this side would be B, and the hypotenuse would be C. So then we could use A squared plus B squared is equal to C squared. So now, if we had the distance formula, we see A itself is the distance from B to C. So the distance from B to C represents A, so we want to square that, plus B would be represented by the distance from A to C, squared, and then the hypotenuse square would be the distance AB squared. Now, observe that in the formula, in the distance formula, we have square roots, right? So because we have square roots in the distance formula, when we square, that would get rid of the square roots, right? So we don't have to bother with the square root sign when we check in to see if it's a right triangle, okay? So for example, let's look at an example. Suppose we're given 3 points, and we're asked to see if it forms a right triangle. So for example, if we were given the points 12, -1, 9, 1, and 10, -4. And here we ask, does these 3 points form a right triangle, right? So does these 3 points form a right triangle? Okay, so we could graph it, and that would give us some idea. Maybe we could make a good guess, right? So question would be, does these 3 points form a right triangle? And that's if they're connected by straight lines, of course. Okay, we could graph, we could do a little sketch, but even if we did a little sketch, we may not be sure, right? So let's just label these points arbitrarily. Let's call the first point A, the second one B, and the third one C. So we could say, we could look at the distance from A to B squared. So A to B squared mean that we do not have to bother with the square root sign. So we could just go ahead and say 9 minus 12 squared plus 1 minus minus 1 squared, and see how much that comes up to. So this comes up to 3 squared, which would give us 9, plus, well, 1 plus 1, minus times a minus, we're going to make this a plus 1. So that's going to become 2, and 2 squared is going to be 4, so this is equal to 13. And now we could do A to C right here, squared. So A to C would be, that would be 10 minus 12 squared plus, we'll have minus 4 minus minus 1 So here we have 10 minus 12, that'd be minus 2, but minus 2 squared would be 4. And here we have minus 4 plus 1, so that's negative 3. And negative 3 squared would be 9. So this is also equal to 13. And then we could look at b to c. That would be the third side squared. And b to c would be the difference between the x values, 10 minus 9 squared, plus the difference between the y value squared, so minus 4 minus 1 squared. So 10 minus 9, that'd be 1. 1 squared is 1, plus minus 4 minus 1 is minus 5, and minus 5 squared is 25. So this is equal to 26. So now the two shorter sides squared, right? The two shorter sides squared, we see add to the longer side. So we can say yes, the given points, yes, the given points form a right triangle. Okay, let's look at one more example. Example B. Do these points form a right triangle when connected by a straight line? Okay, so arbitrarily labeling them A, B, and C, we can do A to B, which would be the difference between the x values, 11 minus 7 squared, plus the difference in the y values, 4 minus 0 squared. So this is 4 squared plus 4 squared, so 16 plus 16, this is equal to 32. And then we could do, this is AB squared. Then now we can do AC squared. Excuse me. And so the difference between the x values would be 3 minus 7 squared, plus the difference in the y values, that would be 4 minus 0 squared. So this is minus 4 squared plus 4 squared. So again, 16 plus 16, that's equal to 32. And then finally we can do b to c squared. So b to c would give us the difference between the x values would be 3 minus 11 squared plus 4 minus 4 squared. So this is negative 8 squared plus 0 squared, which would be 64. Okay, so now again, the two shorter sides add up to equal the longest side. So the two shorter sides squared, that is. The two shorter sides squared do add up to equal the longest side squared. So we can again say yes. This is a right triangle. Okay, so those 3 points do form a right triangle. Okay, that's it for this video. Thank you for watching.